Hypersonic missiles, moving at speeds 5 times the speed of sound, are redefining global military strategy, posing an unprecedented challenge. Unlike ballistic missiles with predictable arcs, these weapons fly lower, faster, and are incredibly maneuverable, evading current defenses.
Extreme heat and pressure during flight necessitate revolutionary materials and precise thermal management systems for successful deployment.
The innovative Scramjet engine compresses air at supersonic speeds, achieving the necessary thrust for sustained hypersonic travel efficiently.
This technology ignites a new, volatile arms race. Several nations are actively developing and
Detecting these weapons is extremely challenging. The combination of low altitude and blinding speed shrinks reaction time dangerously for defense systems.
Traditional radar systems designed for predictable threats struggle significantly with the unpredictable maneuvers and speed of hypersonic targets now.
Historically, technological superiority has always driven military doctrine. Hypersonics,
The future of defense will rely heavily on advanced, networked, space-based sensors for early detection and tracking capability.
Developing effective countermeasures, such as directed energy weapons, requires immense power and precise targeting at these speeds.
The absence of clear international arms control treaties for these weapons increases the risk of miscalculation and potential escalation significantly.
These platforms can carry both conventional and nuclear payloads, blurring the line between tactical and strategic warfare drastically.
New high-temperature ceramics and alloys are critical to withstand the intense thermal load generated at Mach 5 and above. The minimal reaction time encourages a potential launch-on-warning posture, drastically increasing the risk of accidental conflict.
Glide vehicles, utilizing atmospheric lift for maneuverability, present a far more complex targeting problem than traditional ballistic threats.
The plasma sheath generated around the vehicle during flight makes reliable communication and precise guidance extremely difficult and unstable.
Diplomatic channels must be prioritized to establish norms and prevent an uncontrolled, catastrophic spread of these dangerous weapons.
A multi-layered defense strategy combining space, air, and ground assets is essential for a credible, robust interception capability.
AI and machine learning are vital for developing adaptive, real-time flight control systems capable of navigating these extreme conditions precisely.
The arrival of hypersonic weapons has fundamentally changed global strategic calculus, demanding immediate adaptation and sober reflection now.
The unpredictable, dynamic flight paths mean defenders cannot determine the target until the missile is virtually upon them, severely limiting response time.
Initial acceleration often requires a rocket booster stage before the air-breathing Scramjet engine can efficiently take over propulsion at speed.
Traditional deterrence relies on assured retaliation. Hypersonics potentially undercut this, creating a dangerous first strike advantage.
Future defense may involve high-power directed energy weapons, requiring massive power generation and pinpoint accuracy to destroy the target.
These cutting-edge composites must endure temperatures exceeding 2,000 degrees Celsius, retaining structural integrity through the entire flight. Just as the perceived missile gap defined the Cold War, the hypersonic gap is rapidly shaping today's strategic planning and investment.
International cooperation and shared defense architectures are critical to counter this pervasive, borderless threat effectively and affordably.
Test flights are high-risk, expensive endeavors, yielding invaluable data on performance, stability, and atmospheric effects under extreme conditions.
The power of this technology demands responsible stewardship. We must ensure it stabilizes global.
The invisible death threat is real, untraceable, unstoppable, and redefining the very boundaries of modern global warfare, now forever. Flight times for hypersonic missiles are minutes, not hours, meaning the time available for crucial political decision-making vanishes alarmingly quickly.
Maintaining target lock while maneuvering at extreme velocity demands inertial navigation and highly hardened GPS systems with exceptional precision. This new arms race demands colossal financial investment, diverting crucial resources away from other pressing global priorities like education and infrastructure.
Anti-ship hypersonics threaten to render even the most advanced, largest naval fleets vulnerable and potentially obsolete in seconds.
Computational fluid dynamics simulations are absolutely vital for optimizing the airframe design, minimizing drag, and managing the intense heat flow.
Much of this research remains highly classified, fostering an air of suspicion and hindering open.
An offset strategy, leveraging asymmetrical advantages and advanced technology, is necessary to restore
Material failure at extreme temperatures and velocities remains a significant hurdle. Structural integrity is constantly pushed to the absolute breaking point.
Any future treaty must incorporate advanced, verifiable monitoring technologies capable of accurately tracking.
LEO satellite constellations provide the necessary wide-area, persistent surveillance required for reliable, continuous tracking of these new threats.
Engine must seamlessly transition from ramjet to scramjet mode at Mach 4 or higher, a complex and critical engineering feat. The severely restricted decision space significantly increases the chance of misinterpreting an attack, potentially leading to immediate tragic escalation.
Boost glide systems utilize a rocket to reach high altitude, then glide and maneuver through the atmosphere to penetrate existing defenses successfully.
Precise thrust vectoring, adjusting the engine's direction, is absolutely crucial for the high-G maneuvers necessary to avoid terminal interception.
The ultimate dilemma of the hypersonic era remains. The speed of the attack far exceeds the speed of the necessary defensive reaction.
Massive research and development efforts are now dedicated globally to creating an effective defensive answer against this existential threat.
Additive manufacturing allows for incredibly complex, lightweight, and thermally efficient structures necessary for the next generation of hypersonics.
Transparency in testing and clear communication of strategic intent are vital for preventing misperception.
Just as the V-2 ushered in the age of long-range rocketry, hypersonics mark the absolute beginning of truly...
The software controlling these weapons must execute millions of complex calculations per second to maintain flight and reach the target precisely. Control of hypersonic technology is a critical, emerging determinant of future global military and political leadership for decades to come.
Highly maneuverable re-entry vehicles combine hypersonic speed with unpredictable terminal maneuvers, adding another layer of complexity for interception.
While incredibly loud, efforts are underway to minimize the acoustic signature where possible, aiding in the overall covert nature of the mission.
Though technologically challenging, renewed commitment to non-proliferation principles is necessary.
Future interceptors might use electromagnetic railguns or focused energy beams to achieve the necessary speed and destructive power now.
Sensors must be incredibly hardened to withstand the immense thermal and vibrational stress experienced during sustained hypersonic flight.
Accurate assessment is critical. We must avoid both fear-mongering and complacency regarding the true strategic impact of these weapons.
Current tests confirm operational speeds exceeding Mach 10 in some cases, pushing the boundaries of what was previously considered physically possible for flight.
Despite the danger, this represents a monumental achievement in aerodynamic and propulsion engineering, pushing the limits of human innovation further.
The ultimate test for global leaders is managing the inherent risks of this power, ensuring technology.
Notice the flatter, more atmospheric trajectory of the glide vehicle compared to the high-altitude, predictable arc of the traditional ballistic missile.
Heat shielding often involves sacrificial materials that ablate away, dissipating massive amounts of thermal energy to protect the missile core effectively.
The introduction of these weapons significantly complicates maritime security, raising regional tensions,
and command and control systems must operate at incredible speed and resilience, ensuring instantaneous communication and authorization during a potential attack.
Optimizing fuel-air mixture and injection timing is crucial to extract maximum performance from the scramjet while operating under intense pressure.
The long-term risk of this technology proliferating to non-state actors or smaller rogue nations.
Submarine launch platforms add a layer of extreme stealth and mobility, making the task of early detection and warning nearly impossible.
The complex engineering and extreme operating conditions mean that maintenance and pre-flight checks are meticulous, time-consuming, and highly technical processes.
Global security demands immediate, focused attention from the United Nations and other international bodies to discuss and mitigate these risks now.
The combination of speed, low altitude, and maneuverability creates the invisible death, a truly untraceable threat.
Designed for slower threats, current terminal air defense systems simply cannot react or maneuver fast enough to successfully engage a hypersonic missile.
Achieving laminar flow across the missile surface is an aerodynamic marvel, crucial for minimizing both drag and the immense friction heat generated.
Verification is the biggest obstacle to arms control. How can inspectors reliably monitor systems?
Future interceptors must possess incredible thrust and extreme G-force maneuverability to stand any chance of successfully meeting the hypersonic threat head-on.
Testing requires vast, controlled airspace and sophisticated telemetry, limiting the number of nations capable of truly advancing.
The technology is unfortunately no longer confined to major global powers, rapidly spreading to a worrying number of capable emerging economies. Electronic countermeasures deployed at speed further complicate tracking, often creating decoys and confusing the defensive radar system completely.
Miniaturized, high-density power systems are essential to drive the onboard guidance, communication, and control actuators under extreme stress.
The fear and strategic uncertainty surrounding the rise of the ICBM is mirrored exactly in the current global reaction to these hypersonic breakthroughs.
At Mach 5, the missile covers a mile every second. That second, at that sheer speed, is the fundamental, overwhelming advantage over all.
Even carrying conventional payloads, the speed of impact gives hypersonics devastating kinetic energy, making them extremely effective against hardened targets.
AI algorithms constantly calculate and adjust the flight path, autonomously correcting for atmospheric changes and defensive maneuvers in real time.
Agreed international norms regarding testing boundaries and deployment areas are crucial to prevent misunderstandings that could easily lead to conflict.
Significant gaps in current radar and satellite coverage provide clear, unmonitored windows for hypersonic weapons to operate with absolute impunity.
Igniting the air-fuel mixture within the scramjet while air rushes past at supersonic speed is an extremely delicate, crucial process.
Limitations on missile range or the maximum speed could offer a viable pathway towards a future, more stable arms control agreement framework.
Space-based kinetic interceptors using pure velocity offer a potential solution.
The immense internal noise and vibration demand extremely robust, shielded internal components to ensure the sensitive guidance systems can operate correctly.
Establishing clear, reliable communication channels and rapid de-escalation protocols is essential to prevent.
Defending against this requires a fundamental, immediate, and costly shift in the global approach to military defense strategy and investment priorities now.
The political will to fund and rapidly deploy a robust counter-hypersonic defense system is now the single most critical, urgent factor.
Ground-based test facilities like high-speed rocket sleds and plasma tunnels simulate key flight conditions essential for validating component performance.
If offensive capability is met with equally effective, reliable defensive systems,
Air launch systems provide greater range, flexibility, and reduced launch signature, increasing the weapon's overall stealth and surprise factor significantly.
Achieving the necessary thrust and minimizing the engine weight is a non-negotiable engineering compromise, crucial for mission success and range.
The immense reliance on complex software also creates a significant cyber vulnerability.
Mobile land-based launchers are notoriously difficult to track, offering an increased level of survivability and strategic ambiguity before deployment.
Advanced nickel and tungsten alloys, capable of retaining strength at extreme temperatures, are the unseen fundamental heroes of this entire technology.
The complexity of this threat demands collaborative analysis from academic and research institutions worldwide.
The threat is immediate, significant, and evolving rapidly, and the window for effective countermeasures is closing fast, demanding unprecedented action now. The Scramjet is the next leap in propulsion, just as the jet engine revolutionized flight in the last century.
Before ignition, the air must be rapidly cooled and compressed in a fraction of a second, an extremely demanding process for the internal hardware.
Regional arms races are accelerating dangerously as neighboring states perceive a crucial capability gap and quickly scramble to close it.
A truly effective defense requires a fully integrated multi-domain sensor network, seamlessly linking ground radar.
The need for robust thermal protection and high-efficiency propulsion dictates a specific, often larger size.
An informed public debate is crucial for democratic oversight and ensuring that the significant investment in these
Chilling possibility of fractional orbital bombardment systems, leveraging hypersonic reentry, poses a global threat with extremely reduced warning time globally.
Transmitting reliable, high-bandwidth telemetry data back to ground control through the surrounding plasma sheath remains a constant, severe technical obstacle.
The use of the near-space environment for these weapons complicates and potentially violates existing, carefully crafted.
The combined factors of blinding speed and low-altitude atmospheric flight render these weapons fundamentally untraceable by today's conventional detection systems.
Intelligence gathering relies heavily on SIG&T and human sources to anticipate launches, compensating for the lack of real-time technical tracking capability.
The Scramjet is a single-use engine designed for maximum power power are very brief over incredibly high stress duration.
Interpreting the strategic intent behind test launches is difficult and crucial. Ambitious.
The precision guidance system allows the missile to strike highly mobile tactical targets, which were previously safe from conventional long-range threats entirely.
Onboard electronics must be heavily shielded and hardened to survive the severe G-forces, intense vibration, and potential radiation exposure during flight.
All major military doctrines are undergoing urgent, deep revision to accommodate the extremely short reaction times.
Major global powers are now dedicating massive funding and national resources to rapidly develop defensive systems capable of matching the speed and agility of these threats.
Trajectory planning must account for real-time atmospheric conditions, target movement, and potential defensive action, all calculated instantaneously.
Future warfare will be defined not by the size of the force, but by the sheer velocity of the attack and the overwhelming speed of the decision cycle.
This technology creates a fundamental asymmetry. The offense is fast and untraceable, while the defense...
Critical national infrastructure, from power grids to communication networks, is extremely vulnerable to an immediate, devastating, untraceable hypersonic strike.
Repeated thermal and mechanical stress on the materials leads to high cycle fatigue, significantly challenging the reliability and longevity of the weapon structure.
In the heat of a crisis, the lack of crucial warning time greatly increases the chances of a preemptive strike.
International collaboration is absolutely vital. Sharing data, resources, and research accelerates defense.
The control surfaces must adjust rapidly and precisely to maintain stability and execute high-G maneuvers.
Despite the technical advancements, the most stable long-term solution lies in robust, verified arms control.
Launching from non-military aircraft or civilian-looking platforms drastically increases the difficulty of preemptive detection and strategic warning further still.
Even microscopic imperfections in the surface finish can catastrophically disrupt the laminar flow, leading to increased heat and potential structural failure.
The immense cost of participating in this arms race, both offensively and defensively, threatens to completely bankrupt.
The combined challenge of extreme speed, low-altitude flight, and maneuverability makes the invisible death the most common. The immense kinetic energy delivered at impact means that even deeply buried hidden commanders are no longer truly safe from a hypersonic strike.
The weapon's intense heat signature is a double-edged sword, a tracking opportunity for defense, but also a vital guidance cue for the missile itself.
Allowing AI to make autonomous launch decisions driven by the need for speed raises profound and frightening ethical questions for humanity. The only truly comprehensive answer is a permanent, robust defensive shield based in space, providing...
During sharp maneuvers, the vehicle endures crushing G-forces and immense structural loads, requiring a very resilient and perfectly designed internal skeleton.
Technological surprise has always been a catalyst for conflict. The current strategic shock demands a carefully measured and deeply thoughtful international response.
The speed and flight path of these weapons create a frightening risk of airspace confusion, in tragic but tragic...
Internal cooling channels, often using the fuel itself as a heat sink, are absolutely vital for preventing the engine structure.
We must choose stability over overwhelming technological advantage, the future of global security.
Invisileth represents the pinnacle of untraceable military power, an existential strategic threat. The sheer cost of designing, building, and deploying a credible defense against this threat necessitates...
Any deviation from perfect combustion drastically reduces performance. The engine operates on a knife edge.
Regional defense cooperation and collective security agreements are essential force multipliers against an opponent that only respects sheer, overwhelming power.
The delivery of an EMP weapon via hypersonic missile would be devastatingly effective, instantly crippling electronic systems across a vast area without warning.
The specialized thermal barrier coating is the missile's first and most critical line of defense, designed to shed heat and maintain the structural integrity underneath.
The need for near-instant response forces governments to confront the ethical and legal complexities of truly preemptive defensive strikes in action.
Information warfare is increasingly used to sow confusion, disguise weapon development, and mask the precise deployment of these critical hypersonic assets.
Maintaining stable, controlled flight through constantly shifting atmospheric density and immense air pressure is an absolute triumph of flight control engineering.
The only true pathway to long-term security lies in immediate, sustained global dialogue, prioritizing human safety.
The invisible death is not just a missile. It represents a permanent, irreversible shift in the global balance of power. National leaders facing a confirmed hypersonic strike must now make existential decisions in a terrifying window of mere minutes, not comfortably hours.
Wind tunnels operating at Mach 6 and above are essential to physically test the aerodynamics and structural integrity before any costly live flight tests.
Smaller nations are now profoundly vulnerable. Without advanced defenses, they must rely solely on the collective.
Satellites and their crucial ground stations are primary targets, as crippling communication links is a first-step priority in any large-scale hypersonic attack plan.
Precisely managing the internal shockwaves and airflow is critical. Any disruption can cause an immediate engine unstart, leading to total missile failure.
Maintaining a human in the loop for the ultimate decision to deploy remains a non-negotiable ethical and strategic requirement for a stable global system.
Building the necessary infrastructure for tracking and interception, including advanced radars and missile bases, will cost many trillions of dollars over time.
Carbon-carbon composites offer the necessary combination of extreme lightness and high thermal resistance, crucial for the core structural integrity of the vehicle body.
A stable equilibrium might be achievable if defensive technology reliably catches up to the offensive threat.
The inherent inability to track these weapons from launch to impact makes the threat truly untraceable, fundamentally undermining the entire system of deterrence.
Multiple, independently targetable warheads exponential increase the defensive challenge.
Specialized multi-layer thermal insulation is necessary to protect the internal payload bay and guidance electronics from the intense exterior atmospheric heat.
Open scientific exchange and cooperation on defensive technology could actually build trust.
This technology is only in its infants. Future advancements in speed, stealth, and maneuverability will
Pure surface system. The entire system is a single, perfectly integrated organism. Assembly requires micro-level precision to
Clear, rapid, and pre-established crisis communication protocols among global powers are absolutely vital for preventing. Airborne laser systems offer a potential answer, providing a mobile, high-altitude platform capable of rapidly engaging
The inertial navigation system provides crucial, autonomous guidance, backed up by star trackers, maintaining precision.
Our decisions today regarding this technology will dramatically shape the strategic and security landscape for many generations of humans to come.
The invisible death weapon exposes the vulnerability of any nation dependent on slow, conventional defenses, drastically shifting the advantage to the attacker.
A credible, reliable defense system is the key to restoring stable deterrence, ensuring that any first strike is met with
Exotic, high-energy density fuels are required to provide the necessary thermal stability and powerful energy release.
The psychological effect of a weapon that offers absolutely zero warning time creates a profound sense of public.
Coordinated swarms of smaller, networked hypersonic missiles saturate defenses, making it practically impossible for any existing.
Every component must function flawlessly for a short, intense period. There is zero margin for error.
As test data or even failed components are recovered, the risk of successful reverse engineering and accelerated proliferation.
The research and development costs for both the offensive weapons and the necessary defensive countermeasures are truly.
The flight control software must continuously adapt to real-time changes in air density and temperature, crucial for maintaining both stability and directional accuracy.
The invisible death is a global threat. It must be met with a unified, collective, and responsible international consensus.
Defeating the invisible death will require not just money, but a monumental triumph of collective human ingenuity.
Targeting critical financial and data centers could paralyze a nation's economy and information flow, making the hypersonic weapon.
Post-flight analysis of engine degradation is crucial, providing invaluable data for improving the reliability and efficiency of the next generation of components.
Speed has always conferred a massive strategic advantage in warfare. The hypersonic missile simply amplifies this.
Future systems may incorporate active stealth or plasma-based cloaking technology, rendering them eligible.
Finite element analysis is essential for predicting stress points and structural integrity, ensuring the design can rely.
National security budgets are now stretched by the difficult competing demands of investing in both powerful offensive hypersonic.
The ethical ramifications of using such a devastatingly fast and untraceable weapon against any civilian population.
The missile's guidance system must fuse data instantaneously from multiple different sensors to maintain accurate targeting and situational awareness mid-flight.
Responsible media coverage is critical to inform the public accurately, avoiding both reckless sensationalism.
Ultimately, the inherent human drive for self-preservation guarantees that an effective, reliable, and powerful defense. Human reaction time is simply no match for the speed of this threat. Therefore, automated, computer-driven decision.
Automated pre-flight diagnostics are absolutely essential. Manually checking all components under such tight timelines would be dangerously.
A major, targeted hypersonic strike could instantly trigger a cascading global economic collapse.
Targeting nuclear power plants or similar high-consequence facilities could lead to immense, widespread, long-term environmental catastrophe and severe humanitarian disaster.
Radiator panels and specialized heat exchangers are required to move excess heat away from the sensitive internal components and safely into the surrounding airflow.
The military use of near space demands urgent, new international legal governance frameworks to prevent.
Successful interception is technically challenging but entirely achievable through relentless, well-funded innovation specialized.
Mobile launch systems must be incredibly robust, capable of rapid setup and deployment, surviving harsh environments.
Ultimately, the human element, our wisdom, restraint, and capacity for peace remains the absolute last.
The race to reliably see the unseen, to intercept the untraceable, must continue with unwavering commitment.
The perceived threat to global shipping and critical trade routes creates immense instability in the global economy, directly impacting the well-being of all nations now.
Every test flight generates terabytes of complex telemetry data, requiring immense computing power and extremely sophisticated.
New theories of deterrence must emerge, accounting for the unique factors of speed, reduced warning time.
Targeting strategic port facilities could instantly cripple a nation's ability to mobilize and resupply forces.
The internal combustion surfaces experience incredible stress, requiring components to be completely replaced or meticulously inspected.
Detecting covert hypersonic development in closed societies remains an immense intelligence challenge, increasing the.
Even with advanced automation, highly trained human operators remain essential for decision oversight, ethical assurance, and
components must be rigorously tested in extreme thermal vacuum chambers to simulate the intense heat and pressure cycles experienced during actual high-speed atmospheric flight.
The proliferation of this technology fundamentally raises the calculated probability of a rapid, large-scale.
Building the ultimate defense is not just a military imperative. It is a moral, strategic, and ethical necessity for
the successful strike on a densely populated capital city would result in an immediate, unimaginable humanitarian and political.
Non-destructive testing methods are crucial for detecting tiny, potentially catastrophic internal flaws in the complex, high-stress composite engine structure.
Confidence-building measures, such as pre-notifying test launches, can greatly reduce suspicion and contribute to a more stable, trustworthy international environment.
Mobile counter-hypersonic launch platforms are essential to ensure survivability and provide a rapid, resilient defensive response against an unpredictable incoming threat.
While the engine itself is incredibly loud, the flight profile is designed to minimize the detectability of the acoustic signature.
The immense speed of the weapon inherently complicates all legal and international enforcement, making accountability for an attack.
Targeting the key underlying global internet backbone infrastructure could entirely disconnect a nation from the world.
Maintaining the extreme readiness of a system built to operate at its absolute physical limit requires incredibly frequent, highly complex and.
The next generation of this terrifying threat will involve autonomous, networked hypersonic drones.
The world must urgently unite, invest, and innovate immediately. Only an unprecedented collision.
The paradox is clear. While extreme speed grants the offensive advantage, the resultant intense thermature.
Next-generation optical sensors must be specifically shielded and designed to see clearly through the intense atmospheric turbulence.
The tension between a nation's necessary military secrecy and the global ethical need for transparency, or the transparency.
Air-to-air hypersonic missiles threaten high-value airborne assets, such as AWACS and crucial command and control aircraft.
AI continuously monitors engine parameters, making extremely subtle nanosecond adjustments to maximize efficiency and stability throughout the entire flight profile.
Strict multilateral control over the sale and transfer of this critical dual-use technology is absolutely essential.
Naval vessels require specialized vertical launch systems and extremely agile, specialized interceptors.
The zero-defect philosophy is non-negotiable. Even the slightest imperfection in any single component can cause total catastrophe.
A specialized treaty focusing solely on atmospheric hypersonics might be more achievable than a blanket ban.
The defense against the invisible death will not be a single product, but an absolute continuous, evolving search and
forward military bases and key logistics hubs, previously thought to be relatively secure, are now extremely vulnerable to a rapid.
Specialized vibration dampening is essential. Without it, the intense rattling at high Mach numbers would instantly
avoided. Meaningful disarmament requires profound political courage and a compromised national security interests.
Defender of a dense cloud, launched an intentional solution to saturate the impact of attack.
Extended mission endurance at Mach 5 is an incredibly complex challenge, requiring perfect optimization of the engine and all highly precious fuel consumption.
Hypersonics drastically accelerate the arms race. The fear of being left behind is driving immense, reckless, and hasty.
Essential energy infrastructure, such as pipelines and refineries, are highly vulnerable, offering a strategic target to instantly cripple
point site. Hardened cyber defenses are absolutely vital, and the missile's guidance system must be completely protected from both jamming and...
The moral imperative is clear. Every nation must prioritize defensive, stabilizing technology, peace.
The invisible death is real, an untraceable, unstoppable strategic weapon that forces a...
Possession of this technology grants immense strategic leverage, allowing nations to project overwhelming power.
A single test launch consumes vast amounts of money and specialized resources. Every flight in financial...
The high-stakes environment increases the risk of accidental war, where
targeting large dams could cause catastrophic, widespread flooding and total long-term environmental devastation, crippling entire regions instantly and completely.
The thermal management system is delicately balanced to minimize external detection while maintaining a clear...
A dedicated, permanent UN working group is required to continuously monitor, regulate, and...
The counter-missile must calculate and execute a complex, highly dynamic intercept trajectory in mere seconds to successfully meet the unpredictable target head.
Automation in the launch sequence minimizes the possibility of human error, ensuring the incredibly complex weapon system operates with maximum efficiency.
The core strategic challenge remains: successfully defending against a weapon that has already virtually struck before.
Human innovation is relentless and unstoppable. Just as the threat was created, a powerful and reliable defense.
The fear of sudden technological surprise is the single greatest driver of the accelerating pace of this new...
The control surfaces and guidance systems require massive, reliable, instantaneous bursts of electrical power for...
Strategic uncertainty directly translates into volatile global financial markets, impacting trade, currency, and investment decisions.
Targeting low Earth orbit satellites with hypersonic technology could blind a nation's defense and communication systems, instantly achieving strategic preeminence and advantage.
Accurate thermal modeling is essential for predicting heat stress, allowing engineers to reinforce critical areas and optimize the overall thermal management system effectively.
Discrete, non-public, back-channel diplomatic efforts are extremely vital for maintaining communication and negotiating.
Ground-based directed energy weapons using powerful lasers or microwave beams offer a final, last-second terminal...
Reliability in this technology is a life or death metric. The system must execute the mission flawlessly with...
The future of global security will be relentlessly defined by the continuous, high-speed dynamic interplay.
The race to reliably see, track, and intercept the untraceable invisible death has officially begun, and the ultimate global...
The current imbalance in defense spending, heavily favoring offensive development, must be urgently corrected with massive, targeted
Non-invasive rapid diagnostic checks are essential for maintaining the missile's extremely high operational readiness without requiring
of it. The sheer speed of the threat forces rapid, less considered retaliation, fundamentally undermining the moral and
Targeting massive, high-power military communication arrays could instantly isolate deployed forces, creating a devastating strategic.
Extensive simulation of engine unstart is critical. Understanding and designing a reliable restart protocol at high velocity is an essential.
The sheer magnitude of the common shared threat is fundamentally reinforcing and strengthening the strategic importance.
Defensive targeting relies entirely on multi-sensor data fusion, seamlessly merging thermal, radar, and optical inputs to create one.
The incredibly high power-to-weight ratio of the engine is the single most critical factor enabling the missile to achieve and.
Despite the enormous strategic threat, the sheer power of collective human intellect and our unwavering ingenuity.
The invisible death weapon's most profound strategic impact is the total, fundamental erosion of crucial strategic warning time. Targeting strategic nuclear submarine bases could severely compromise a nation's ability to execute a second strike deterrent.
Manufacturing these high-precision components requires completely specialized facilities, strict cleanroom conditions, and incredible.
The terrifying worst-case scenario involves total defense saturation, where the sheer number of incoming threats completely.
Space-based kinetic interceptors offer the ultimate last-ditch defense, capable of destroying the incoming threat before it even truly.
Given the immense cost and complexity, specialized programs are already underway to determine the safe and reliable possibility of reuniting.
A truly effective defense absolutely requires a collaborative, shared global architecture.
Defensive AI is crucial. It must execute complex targeting solutions in milliseconds, a task far beyond the speed and.
The search for even higher energy density fuels continues relentlessly, promising future hypersonic weapons with dramatically.
Let the breathtaking human ingenuity that created this weapon also be powerfully directed towards creating a.
Invisible death has irrevocably altered the face of global security. The world must urgently adapt or face the immediate.
The sheer scale of the speed advantage means that at the moment the missile is first detected, the point of no return for any feasible, reliable defense has.
Every component is engineered for an intense, single, extremely high-performance flight. And they're quite literally designed to be.
The pressure to act preemptively against an untraceable threat creates an acute moral and legal dilemma for all nations.
The ability to instantly decapitate national command and control with a rapid, untraceable strike is the single most
Agreements. Meticulous, detailed analysis of all flight data is absolutely essential to continuously refine the missile's trajectory.
Re-establishing global strategic stability is paramount. It requires a collective global commitment.
The defensive interceptor is arguably even more complex than the offensive missile itself, requiring greater speed and superior instantaneous.
All onboard electronics must be extremely hardened against a potential electromagnetic pulse attack, ensuring the missile's ability.
This arms race will either culminate in a new era of profound, stable peace through effective defense.
The message to all global powers is starkly simple. Adapt your defenses immediately, invest heavily and.
Speed factor radically shrinks the operational distance, meaning weapons launched from halfway across the entire globe can now strike their targets in mere minutes.
The ultimate technical goal is a fully reusable hypersonic vehicle, demanding materials and engineering far beyond our current.
Diplomacy must be continuous and proactive. Waiting for a crisis to begin is no longer an option.
When the sheer, terrifying speed of impact means that a devastating strike on a major population center would yield virtually zero time.
Is the smallest microfracture or thermal stress point must be absolutely detected and corrected before every single subsequent flight test.
Despite the terrifying power of the technology, the final outcome remains in our collective hands.
A fully operational, integrated, multi-layered defense network.
Material science breakthroughs are continuously needed, driving both the offensive
and the negative.
The post-hypersonic world is inherently more dangerous, demanding a completely new level of global.
The invisible death threat is real, untraceable, unstoppable, and redefining the very boundaries of modern global warfare